Welcome to EDU World Space.
In this problem, we're given that there is an object with a circular cross-section that is submerged in water, and we know that the radius of this circle is 8 meters. Let's assume that the center of the circle is our origin, so that is 0, 0. And we have then the x and the y-axis is such. Now, let's assume that let's actually write what we know. We know that force is equal to pressure times area, and pressure is equal to rho times g times depth times area. Now, we know rho, and that is 1,000. We know g, that is 9.8 meters per second squared. Now, we need to determine the depth and the area. Now, as you can see, we have an object with a circular cross-section, and we know that radius is 8, so equation of that circle would be x squared plus y squared is equal to r squared, so that is 8 squared. From this, we can write x in terms of y as x is equal to 64 minus y squared square root. Now, if that is x, now let's zoom in. We have this circle. This is the center. So the area would be, since we need the area in order to calculate the force, area would be the area of this thin strip summed up over all this or along the diameter of this circle. And this would be, since we just found what x is in terms of y, so on one side we will have square root of 64 minus y squared. And since circle is symmetric, we will have the same length on the other side, so 64 minus y squared. And let's assume that the thickness is dy, since we assumed y-axis to be the vertical axis. So the area of that thin strip would be, let's assume that that is dA, meaning that it shows us that there's a differential area. It would be total length, which is 2 times square root of 64 minus y squared multiplied by dy. Now let's say that we are measuring y, since this is our origin. This is positive y, but don't forget pressure depends on the depth, and the depth, we actually are measuring the depth from the surface of the water. So if this distance is 4 and if the radius is 8, it means that total distance from the origin to surface is 12 meters, and the depth would then be 12 minus y. So this is d. So we know what d is, we know what a is. Let's calculate then the force acting on this very thin plate. That would be df. So df would be rho times g times 12 minus y. This is depth multiplied by infinitesimal this differential area, that is 2 times square root of 64 minus y squared times dy. Now, we would find the total force acting on this object if we were to sum those thin areas up. So we could use Riemann sum. So total F would then be limit as n approaches to infinity, summation over I from 1 to n. We have rho times g times 12 minus y, I times 2, 64, 2 times square root of 64 minus y, I squared times delta y. We can write this one as an integral. Now, since the center again is the origin, and since the radius is 8, this would be then y is equal to negative 8 level, and the upper bound will be y is equal to positive 8 level. So the integral limits of the integral will be negative 8 to 8. We have rho times g, where rho is 1,000, g is 9.8. We have 2, this is a constant again. We now have 12 minus y times square root of 64 minus y squared dy. We can write this one as 19,600 integral negative 8 to 8, 12 minus y times square root of 64 minus y squared dy. Now we can separate this integral, since we have 12 minus y, so we can multiply 12 with this and negative y with that and write this integral as 19,600 is just a constant. we have integral from -8 to 8. This is 8 at infinity. We have 12 times square root of 64 minus y squared dy minus integral from -8 to 8 y times square root of 64 minus y squared dy. And if we were to evaluate this integral, we would find the total force acting on the side of this object with circular cross-section as 2.36 10 to the 7 newtons.